Hello and welcome to another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 9, Lesson 7 on final work with quadratic equations. This is our final lesson in Unit 9, and what we're going to be looking at today are various ways over this unit and the last unit that we use to solve quadratic equations. So without further ado, let's get right into it and review the major ways that we've solved quadratics. All right, we have four distinct methods for solving quadratic equations. The first one we ever saw was completing the square and using inverse operations. Then we moved on to using factoring and the zero product law. We also saw the quadratic formula in our last lesson, and finally we can also solve them graphically using calculator technology. All right, you are expected to come out of Algebra 1 and be able to solve them in each one of these four ways. Now, sometimes in a given problem, you'll be given choice. It will simply be, find the solutions to this equation, in which case, if you love the quadratic formula because it's real plug and chug, you could do that. If you're comfortable with technology, you could graph. If you like factoring and the problem is able to be factored, knock your socks off. And if you're comfortable with completing the square, that works great as well. But many times we will be specified the method with which we have to solve the problem. And you may not like that. You might say, well, I learned one way really well. Why do I have to know the other ways? Well, that's just sort of the way it works. And I apologize for that, but I'm not the one that writes the rules on it. So in exercise 1, let's review all the methods except for the graphical method. Exercise number 1. Solve each of the following quadratic equations using the required method. First, arrange the equations so they are set equal to 0. All right, so basically every method that we use to solve a quadratic equation requires it to be set equal to 0 except for completing the square. All right, but certainly factoring, certainly using the quadratic formula, even using technology, it's helpful for it to be equal to 0. But let's take a look at letter A. Solve by factoring. X squared plus 5x minus 12 is equal to 8x minus 2. All right, well, I'd like you to pause the video, given that we did an extensive number of these in the last unit. Pause the video and see if you can solve this equation using the zero product law and factoring. All right, I've got to get the equation equal to 0 first. So I'm going to subtract an 8x from both sides. And I'm going to add a 2 to both sides. All right, nothing combines with the x squared. A 5x minus 8x is a negative 3x, and a negative 12 plus 2 is a negative 10. All right, once I've got it equal to 0, I can now factor this trinomial. I'm looking for two numbers whose product is negative 10 and whose sum is negative 3. Those are going to be x plus 2 and x minus 5. Once I've got those two factors set equal to 0, I can set each one of my factors equal to 0. And it's now a pretty easy job to finish this out, giving me x equals negative 2 and x equals positive 5. All right, so if you are told to solve a quadratic by factoring, this is how you do it, right? Get the quadratic equation equal to 0, factor the expression that's equal to 0, set each one of those factors equal to 0, and solve the two resulting equations. It's pretty easy, all right? Let's take a look at another one, letter B. Solve by completing the square. All right, yet again, here is one that you've had plenty of practice on. I'd like you to pause the video now and see if you can solve this by completing the square. Keep in mind that when we complete the square, and maybe there's a little bit of a mistake in the directions here, we don't actually have to have the equation set equal to 0. What we need is we need the square, the x squared and the x to the first terms over here, and we actually need all the constants over here. So pause the video now and see if you can solve this equation by completing the square. All right, so first thing I'm going to do is I'm going to add a 3x to both sides, and I'm going to actually subtract a 24 from both sides. Maybe make that look like an x. Okay, on the left-hand side, then we have x squared minus 12x, and on the right-hand side, we have negative 20. All right, we could get the whole equation equal to 0, but then we would have to throw the negative 20 onto the other side. All right, I need to take half of negative 12, which is obviously negative 6, square it and add it on, and that's going to be 36. So I'm going to add a 36 to both sides. This then factors as x minus 6, quantity squared, is equal to 16. I can take the square root of both sides. That will give me x minus 6 is equal to plus or minus the square root of 16. That's actually pretty nice because the square root of 16 is a nice number, is 4. So I'm going to have x minus 6 is equal to positive 4 and x minus 6 is equal to negative 4. I'll add a 6 to both sides and I'll get x is equal to 10. Add a 6 to both sides here, and I'll get x is equal to 2. All right, so 10 and 2. Simple enough. Now let's get a little work with the quadratic formula. All right, here we go, letter C. Solve using the quadratic formula. Express your answers to the nearest tenth. All right, awesome. Now with the quadratic formula, you have to have it all equal to 0. So pause the video now and see if you can work through this, finding two answers accurate to the nearest tenth. Obviously, you'll need your calculator in order to do that at some point. Pause the video now and see if you can work through this. All right, first things first, let's get it equal to 0. So I'm going to subtract a 5x and subtract a 15 from both sides. All right, on the left-hand side, we're going to have x squared minus 8x plus 1 is equal to 0. All right, so now remember my quadratic formula is x equals, let's see if I can fit it in here, negative b plus or minus the square root of b squared minus 4ac all divided by twice a. Maybe make that look a little more like a b. All right, so here we go. X is equal to negative b, which is positive 8, plus or minus the square root of negative 8 quantity squared minus 4 times a times c, all divided by 2 times a. Okay, let me just X out here so I can open up my calculator. Awesome. Now what I really want to be careful about is getting that number underneath the square root correctly. So I've got negative 8 squared minus 4 times 1 times 1. Enter, and that's going to be 60. All right, so I've got a 60 underneath there. I'm going to just kind of keep this in this view because I'm going to have to bring that calculator out in just a moment. 8 plus or minus the square root of 60 all over 2. Okay, and I talked about this a little bit in the last lesson, but let me reiterate it now. Since we're looking for the answers here to the nearest tenth, we're not looking for simplest radical form or anything like that. There is no need to simplify the square root of 60. There's no need to divide anything by 2. Okay, what we want are two answers. One of them being x equals 8 plus the square root of 60, all divided by 2. And the other one being 8 minus this, whoops, that's not 8. Let's try that again. X equals 8 minus the square root of 60 divided by 2. All right, I'm looking for both of these just to the nearest tenth. So let's do it. We've got, I'm going to put my fraction bar in. I've got 8 plus the square root of 60, all divided by 2. And that's going to be 7.9. rounded to the nearest tenth. And let's do now our, can I do that? Yeah, I can just modify it like that. Probably would have been faster to just retype it in, but 8 minus square root of 60 divided by 2, and that's going to be 0.1. All right. And those are our two answers, 7.9, 0.1. That's it. All right, now let's go back to our full screen, move it all the way up here, and let's take a look at letter D. Solve using the quadratic formula. Express answers in simplest radical form. All right, so this is very, very similar to letter C. The big difference is we're going to have to simplify some radicals, divide through, etc., etc. So I'd like you to pause the video now and play around with that one. That has got to be the ugliest looking quadratic formula I've ever seen there. But let's do it. So the first thing I want to do is draw a line like this to give myself some room. I'm going to add a 2x and subtract a 7, add a 2x and subtract a 7. That's going to give me x squared plus 6x minus 5 is equal to 0. All right, I can now start cranking with the quadratic formula. I've got negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. All right, let's figure out what that number is underneath the square root. Bring my calculator over here. I've got 6 squared minus 4 times 1 times negative 5. That all looks good. Looks like I've got a 56 underneath the radical. Hold on, let me just do something really quick. 56 divided by 4, 14, yep. All right, so I've got x equals negative 6 plus or minus the square root of 56, all divided by 2. Go back to my full screen view. All right, now we've got to do the simplifying. Now, you just saw, I was looking to see if 56 was divisible by 4, and it is. 4 goes into 56 14 times. That's our biggest perfect square that goes into 56. I know that because no other perfect square goes into 14. So I can now rewrite this as negative 6 plus or minus 2 times the square root of 14, all divided by 2. And as my final step, I need to now distribute the division by 2. X equals negative 6 divided by 2 plus or minus 2 divided by 2 times the square root of 14. Negative 6 divided by 2 is negative 3. 2 divided by 2 is equal to 1. You can write it, but mostly you will not see it written since it's a coefficient of 1. And we get negative 3 plus or minus the square root of 14. Right? Now, this is a longer problem than this one because at this point, all we have to do is crank the two expressions into our calculator, evaluate the decimals, and move on. In this case, once you get here, if you've gotten here correctly, then you've done the quadratic formula beautifully. The rest of this is simplifying. It has nothing to do with the quadratic formula. But of course, if you simplify incorrectly, you end up getting points taken off of whatever. All right? Now, one of the last things that we want to explore with quadratic equations is that some quadratic equations have no solutions that are real numbers, which is weird, right? Now, we can see why this is both graphically and using the quadratic formula, all right? So let's take a look at exercise number 2. The quadratic function y equals x squared minus 4x plus 13 is shown graphed below, all right? Letter A. Explain how the graph shows that the equation x squared minus 4x plus 13 equals 0 has no solutions. So how is it, explain to me how I can tell that this equation has no solutions based on the fact that basically I've graphed a function that is based on that equation, or maybe this equation is based on that function. Pause the video now and think about this for a moment. Well, it's this simple, right? This equation is solving for the values of x where y, right, is equal to 0. And yet, there is no location where y is equal to 0, right? The function has no zeros, so this equation can't have any real numbers as its solutions, right? The function has no zeros since it doesn't cross the x-axis. Now, that's amazingly weird, right? Because the quadratic formula I mean, you just plug numbers in, you evaluate, and you get your zeros. So how is it possible that a quadratic equation won't have any solutions given that the quadratic formula is just sitting there waiting to give them to us? Well, let's take a look at letter B. What happens when you try to solve x squared minus 4x plus 13 equals 0 using the quadratic formula? Explain how you can tell this equation has no solutions. Fantastic. Okay, so what I'd like you to do is pretend the equation does have solutions and try to find them by using the quadratic equation to solve that. Pause the video now and take a shot at it. All right, let's do it. So here we go. Let me write down the quadratic formula again. X equals negative b, plus or minus the square root of b squared minus 4ac all over 2 times a. All right, well, so let's see what happens. This is a situation where a is equal to 1, b is equal to negative 4, so negative b is equal to positive 4, plus or minus the square root of negative 4 squared minus 4 times 1 times 13, all divided by 2 times 1. All right, fair enough. So far, so good. I'm not seeing anything wrong here, getting a little nervous. So what do I have? I've got negative 4 squared minus 4 times 1 times 13. So negative 4 squared minus 4 times 1 times 13. That seems fine. I get negative 36 under the square root. So I'll get 4 plus or minus the square root of negative 36 all divided by 2. All right, let's go now to our full screen. And let's pause for a minute, right? Here are my solutions, right? So what? Why can't I finish, right? Well, the real rub of it is this, the square root of negative 36, right? What is that equal to? Well, there's 2 logical choices, 6 and negative 6. But 6 times 6 is positive 36. And negative 6 times negative 6 is positive 36. In fact, a positive times a positive is a positive, and a negative times a negative is a positive. So there is no real number that when you square it will give you negative 36. So the square root of negative 36, right, is not any real number, right? Now again, this is very important to understand. A lot of times we'll say you can't take the square root of a negative number, right? Because again, what would it be? Right? A positive times a positive is a positive, a negative times a negative is a positive. So how in the world can you multiply 2 numbers together, right? Square the same number, multiply 2 of the same number together to get a negative under here? And the answer is you can't. So it's no real number, which means there are no real solutions. So let me put that down. Therefore, there are no real solutions. Now, notice I'm trying to be a little bit careful with my language, right? This is not any real number, therefore there are no real solutions, which you can definitely tell by just looking at the graph because it never hits this real number line. In Algebra 2, you're going to learn about something called imaginary numbers. And all of a sudden, you will be able to find a solution to this equation. It still won't cut across this x-axis, all right? But you'll at least have solutions to quadratic equations where there's a negative underneath this square root sign, all right? But for now, if there's a negative underneath that square root sign, there are no solutions to the equation, and the parabola, right, that sort of is, based or analogous to this equation will never touch the x-axis. All right, so let's talk about this a little bit, okay? Whether a quadratic equation has any solutions that are real numbers depends on whether the expression under the square root, known as the discriminant, is negative. If it is negative, then the square root cannot be found and the equation has no real solution. So it's all about just that value, the b squared minus 4ac. That value is critically important. If it's positive or 0, then what's going to happen is that our quadratic equation is going to have solutions and the parabola that it's based on will touch the x-axis. On the other hand, if this value is negative, b squared minus 4ac is negative, then the quadratic equation will have no real numbers as solutions and it will not touch the x-axis. So let's take a look at that idea in exercise number 3. For each quadratic equation shown below, use the value of the discriminant, b squared minus 4ac, to determine if it has any real solutions. Verify by sketching a graph using the standard window. All right, cool. Let's talk about this. So I'm not going to go through and solve for the zeros of this equation. All I'm going to do is figure out what b squared minus 4ac is. All right, so let's take a look. So b squared minus 4ac in this case is going to be negative 10 squared minus 4 times 1 times 22. And that is going to be equal to what? Well, let's take a look. We've done this lots of times. All right, we've got negative 10 squared minus 4 times 1 times 22. I think that's what it was. 4 times 1 times 22. And that's going to be equal to 12. 12. So yes, real solutions. Now, in theory, what that means, if I now graph y equals x squared minus 10x plus 22, I should see it cross the x-axis. Let's take a look. Let's see if that's actually the case. Let me go over here to my graph. I'm going to have x squared minus 10x plus 22. All right, I want this in the standard window, which is negative 10 to 10, negative 10 to 10, etc. So I'm going to go into my window settings. Those are good. Luckily, I can set this just once, and then I don't have to keep resetting it. And enter. And enter. And there it is. Right, great, yeah. Awesome. It crosses the x-axis here, and it crosses it here. I don't need to get it perfectly. I just want to do a little sketch real quick, right? It kind of looked like this, and it crossed the x-axis, right? It's got real solutions. Let's do letter B together. Let me go back to my full screen. All right, let's take a look at x squared plus 6x plus 11 equals 0. Again, the discriminant, b squared minus 4ac is going to be 6 squared minus 4 times 1 times 11. All right, so 6 squared minus 4 times 1 times 11. Oh, typing all of this in and it's doing nothing because I'm not on the right screen. 6 squared minus 4 times 1 times 11. Yep. And that's negative 8. So no real solutions. Now in theory what that should mean is if I graph y equals x squared plus 6x plus 11, I should never see it hit the x-axis. Let's take a look. All right. So let's go back here. All right, I can just delete that out. X squared plus 6x plus 11. Enter, and look at that, right? Now my parabola comes down, right, and then misses my x-axis, never hits it, right? So let me just do a little sketch, right? Never hits this axis. And again, keep in mind, right, that's where the equation would be equal to 0, right? The equation would be equal to 0 wherever it hits that axis. So what I'd like you to do now that we've worked through 2 of these is I'd like you to work through the other 2. Now, one little heads up before you hit letter C. Letter C is negative x squared plus 2x minus 2 equals 0. In this case, a is equal to negative 1. And that makes a difference, right? Because it's part of the discriminant's calculation. So pause the video now and work through both of these. Figure out what the discriminant values are. If they're positive, then it should have solutions. If they're negative, it shouldn't have solutions. And then also produce graphs to verify your answers. Pause the video now. All right, let's go through them. So for this one, b squared minus 4ac is going to be equal to 2 squared minus 4 times negative 1 times negative 2. All right, let's bring forth the calculator. All right, we've got 2 squared minus 4 times negative 1 times negative 2. I did it again. Every time I'm like, okay, I'm cranking this in, and then I don't even look at the screen. 2 squared minus 4 times negative 1. I'm going to remember on the next one. I am. All right, enter, and what do I have? I've got negative 4. Negative 4 is my discriminant. So that should tell me that no real solutions. All right, let's see if that's actually the case when I graph it. All right, of course I'm going to remember to do that. All right, I've got negative x squared plus 2x minus 2. And look at that yet again. My parabola misses. I'm trying to make that, well, there we go, a little bit more highlighted. Misses the x-axis. It gets close. Real close, right? And the discriminant value is close to being positive. It's only negative 4, but it still doesn't hit the axis, right? So we get something like this, right? And misses that x-axis entirely. All right, let's do the last one. Okay, in this case, my b squared minus 4ac is equal to negative 4 squared minus 4 times a times c. Okay. Lots of back and forth here. My apologies for that. This time I'm going to remember to go over to this screen, and I'm going to have negative 4 squared minus 4 times negative 2 times 7. Just make sure I've got that all incorrect. Yep, that's equal to 72. So yes, real solutions. All right. Let's take a look at the graph, see where it intersects. Hopefully it does, or something's wrong. Negative 2x squared minus 4x plus 7. Enter, and there we have it, right? Definitely solutions. One there and one there. I don't really care what they are. I just can see them. And so, you know, just kind of circle them to illustrate. Right? So, it's kind of interesting, right? Now, you've definitely run into linear equations that have no solutions, but quadratics, it really makes sense, especially graphically, how a parabola can just entirely miss the x-axis, right? And this is when we're thinking about like equations set equal to 0, right? So that we can really just, we got this benchmark. Does it hit the ground or not, right? You know, or is it completely below the ground as it is in letter C? Or is it completely above the ground as it is in letter B? Well, that's kind of neat. Let me just put that away real quick. So, you know, the idea though is that sure, we can see it graphically, but we can see it very easily with quadratic formula if we simply examine what's underneath the square root and whether or not that quantity is negative or non-negative. That's it. All right, let's wrap this up. So today we really kind of did two distinct things, right? One thing that we did is we reviewed all 4 major ways that we solve quadratic equations. Now, we didn't really solve one graphically, but we did kind of look at some graphs at the end there. And then the other thing we looked at were quadratic equations that have no real numbers as solutions. And that all boils down to whether or not the number under the square root is negative. If the number under the square root is negative, well, then the quadratic equation has no real solutions. And if it's either positive or 0, the quadratic equation will have real numbers as solutions. You'll be playing around with that a lot more in Algebra 2. For now, I just want to thank you for joining me for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.